can't wait till you get to high school. Here you go. Write this down. Direct variation. Also known as, aka, varies directly. Does that make sense? Stop me there if that doesn't make sense. The basic gist, boys and girls, of direct variation is this, it's kind of logical in that as one number goes up, the other does as well. For example, direct variation would be this. If you were driving in your car and you used 5 gallons to go 100 miles, if you went 300 miles, would the amount of gas you use be more than 5 gallons, or less than?
Depends.
No, it wouldn't depend. All right. Your gas mileage will stay the same. If you use 5 gallons and you went 100 miles, if you went 200 miles, how many gallons do you suppose you'd use, Joseph? No, boy.
10.
10 gallons. That is direct variation, because as this number went up from 1 to 100, 5 went up from 5 to 10. Believe it or not, there's something called inverse variation, whereas one number goes up, the other one actually goes down. But we won't talk about that today. What's important to know about this is a couple things. First of all, write this in big, bold, beautiful letters. You ready? I'm going to make this. What color would you prefer I use?
Orange.
All right. Good. Somebody said orange. Y equals K X. Y equals KX. Anybody an Illinois fan? Come on, let's hear it. Somebody out there, Illinois? Are there Illinois fans out there?
I have no clue. Probably not.
Which looks a lot, ladies and gentlemen, like linear equations, does it not? Y equals mx plus b, except it's missing the b, has a k instead of the m. Instead of it, it really still would be the slope of that, but there's no b over there. That is because, well, let me put this down here first. What color should we go back? That is because of this. Why? Is that making it look too messy? Sometimes you can overdo the embellishment. Am I embellishing too much? Where's my artsy people out there? Is that too much? Just say it if it is. I'm not afraid. Wait, where was I at? Oh, I have to label this first. This letter K, is called the constant of variation. The constant of variation. Which, Zachary, if you're paying attention here, is this. Let's look at the example that I went to great strides to give you before. If this is my x, which is usually is when we make a table, we take the x and do something to it to get the y. What do I multiply 5 by to get 100? Anybody, just shout it out.
20.
No, 5 times 10 is not 100. Thank you, it's 20. My constant of variation is 20. Guess what 10 times what gave me 200? 20. For something to direct very directly, variationally here, every time I know the gallons, I would always have to multiply it by 20 to get the other number over there. It is my constant. Constant means, anybody? Does not change. This is a constant, does not change. Which goes back to this little saying right here. In order for things to be very, very directly, it simply means this, that it is proportional. And if you remember the definition of proportional from back in the day, two things had to happen. Does anybody remember? Oh, I am literally a failure. When you graphed something, and it was proportional, do you remember what two things had to be true? Anybody? Grace? It had to be a straight line. And, Grace, do you know the other thing? No, that's the test for something to be a function. And you talking about the vertical line test? No, that's not that. Had to be a straight line and, Joseph?
It has to go through the origin.
Thank you very much. Go through origin. Which, going back to our linear equation little discussion there, which you didn't get, but I'll say it again for my own personal benefit. This is like slope-intercept form, but what would be my letter B always? If it goes through the origin, the y-intercept is always 0. So this would actually be plus 0 every time, but who wants to put that in there because it doesn't really mean anything. If I were graphing this for my little gas mileage thing here, what would it look like? Well, it would look like this. Here is 5 gallons that give me 100 miles. Here is 10 gallons that give me 200 miles. 0 gallons would give me how many miles? 0. Look at that handy dandy little line there. Could I have negative gallons?
No.
If I drove in reverse, would I actually gain gas?
No.
I could. No, you can't. Distance cannot be negative there. So, let's take a look here. Now, you being 8th graders who are incredibly excited about all of this, if I have this equation, if I manipulate that, what other 2 equations could I get from that? Wait, can I get 2 from it? Maybe I only get 1 from it. I could solve, I could solve this. This is solved for y. What would this be solved for k? If I said solve this for k, fish, k would equal what?
Is it like y over x?
Yeah, y over x. Why? Because I divide by x, I divide y by k. This is the same equation. And if I solve this one for x, x would equal what? Who said it? Is that Joseph again? Kids, where did this Joseph guy come from? Where did he come from? This, boys and girls, is the acceptable form. The other ones are true, but you usually don't see that there. You usually don't see these, but they're true. This, if you knew what x was and y was, you'd always be able to solve for k by dividing y by x. Are you ready for some fun and excitement? What if I had this? If you had a table of x and y values, and this was 0, and this was 0, which it would have to be, and this was 4, and this was 12, and this was 8, and this was 24, and I asked you what k was, what is my constant of variation there? I see. Olivia? 3. It's whatever you multiply x by to get y. The equation I would have is y equals 3x. My letter k is that right here. Boy, this gets better all the time. What if it was written in this form? What if it was 2, 8, and you had another point that was 4, 16, and another point that was 8, 32. What would be my direct variation equation? What would this be? Y equals what times x? Emily, I see it. Say it. No, you're going to say it. Y equals what times x? What? 4. Yeah. Y equals 4 times x. Because you want times 4 to get to this, times 4 to get to that, times 4 to get to that. Here we go. Write these down. Y minus 12 equals x. How about y over negative 3 equals x? How about 3y equals x? And how about 2xy equals 8? Now, what I would like for you to do is with the members of your table group, discuss and tell me which of those 4 is an example of direct variation and which one is not. Which of those 4 is direct variation and which of those is not direct variation? Again, use a think tank here. Use a think tank. Look at Lauren is looking at her notes. She's comparing what are. Just write, give me a yes, yes, no, no, or no, yes, no, yes, or yes, 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 yes. Maybe they all are, maybe none of them are. Talk to your people. Work as a group. Listen to Jackson. He's got it all ironed out there. I don't hear a lot of chatter, but hey, why not? Lauren, maybe Zach will help you. Tell me which of those are direct variation, which one is not. Noting the forms of direct variation that I gave you.
Yes.
Mr. Khan, is there only one?
No, I don't know what there is. I don't know. For all I know, they could all be direct variation. I don't know. I didn't look at the answers. I just want you to tell me.
Are you saying the answers are in the book?
I am saying the answers are in my book. It is practice problem A through D, but you don't have the answers for that. Think about the forms I told you, how it could be written. Can you get those to be in the form y equals kx? Yes or no? If you can't, then it's probably not. If you can, then it probably is. In some acceptable form. This is turning into be quite a shambles. All right, designate a person from your table to be the answer to this pair here. And all you need to do is raise your hand. In your table group, just one person from your table group, who believes this is an example of direct variation? Raise your hand from your table.
For yes?
For yes.
Oh,
Everybody thinks that this is a no.
Yes.
Yes
Yes.
or no?
It's a
No.
no.
It's a no?
No.
Yes.
Alright, so everybody says no. How about this one? Raise your hand if you think it's a yes. Oh, see you people, now you're just all scared.
I'm not scared. I think yes.
How about this one? Who says yes? Oh, see, now everybody just jumps on. Wait, only one person from your table, Bob. Either you or Chase. I can't have you out. So everybody says yes.
Hey, we go down together. So.
How about this one? Yes or no? Wait, are you saying yes or no, Chase? Pick something. I got Clausing your table saying yes, and Chase's table saying yes. Oh, you're just going because you're taking those people off. Is your table going with yes?
Yes.
Oh, no, everybody, you guys must have jump on because maybe you're right.
Yeah, we're yes.
I'm going to go 50-50.
Yeah. Okay. So.
Alright, first of all, this one. You have to be able to write it in the form of y equals k, some number times x. Which would mean, if you are solving this for y, what's going to happen? You're going to divide by 2 over x, and you get 8 over 2x, which is actually 4 over x. X cannot be in the bottom of the fraction. It has to be in the top. Okay, so you are right. This one is not. This one is not. The second one, again, solving for y, you would add 12 over there. And if you did, that's the y-intercept. There's no way this goes to the origin. So yes, this one is not direct variation. This one here, if you solve for y, what do you get? Multiply both sides by a -3. You get y equals -3x. Yes, that is your constant of variation is -3. That would work. And this one here, to solve for x, you divide by 3. Can you have x over 3? Yes or no?
Wait.
Yes.
No.
Yes.
No. I say no.
You certainly can. Why is that?
Yes.
This is the same thing as saying y equals 1/3 x. This is 1/3 x. The x can be on the top, it can never be on the bottom, so this is also yes. These two were examples of direct variation. The constant of proportionality here, or the direct constant of variation was 1/3 there, and the constant here was -3. Those are those things. Now, as an assignment, you ask, what shall we have?
What shall we have?
Well, obviously, if you